Hi, good afternoon. Um, so I would like to thank organizing team and the principal of DVS College of Arts and Science, okay, and all the faculty members to give me the opportunity to present some of my research work here, okay. So I will not bore you very first thing because my research is completely towards nuclear and particle physics, okay, especially radioactivity, okay. You know, Mary Curie, yeah. Why is she famous? Hmm? Silence. Yeah, why is she famous? Mary Curie. Hmm? Yeah, why is she famous? Hmm? Actually, she found out very fast radioactive materials like radium, okay, and polonium, right? Okay. So, and one of the radioactivity word is that particular word coined by Perry Curie and Marie Curie, okay, husband and wife, okay. They are both are from Polish scientists, means what you call Poland, okay. Both are from the Poland Polish scientists. They invented the word radioactivity, okay. So, my research work also, okay, most of my work related to the polonium or radium, thorium, like that. Okay. So this is the outline of my presentation: introduction, instrumentation, materials and methods, result and discussion, and summary. Okay. And what do you mean of radioactivity? Any idea about radioactivity? Hmm? Yeah, you know the definition. Many times already studied in +1, +2, right? Okay. What do you mean of radioactivity? It's a spontaneous distribution of okay, emission of radiation, okay, means by the unstable nuclei. So that is what we call the radioactivity. Okay. But radioactivity is everywhere throughout this universe. See the diagram, okay, our picture here. Whatever the picture is here, okay. See, whatever the life path is there, throughout the life path, radioactivity is there. Okay. See in your house, okay. Next, if you take your college, okay, or water body, foods, okay, or food traps, okay, or water animals, okay, everywhere radioactivity is there, okay, even including human body, okay, including human body. You know, what are the best places the radioactive materials can stay in your body? Hmm? Hmm? Your bones, okay, bones are the best. One. ಸ್ವಲ್ಪ ಕೆಳಗಡೆ
ಅಲ್ಲ ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಕಮ್ಮಿ ಆಗಿದೆ ಅಂತ.
ಹೌದಾ? ಹಲೋ. Okay. So see how the radioactive materials, okay, which come enter into the human body. Okay. Very first thing is that the environment. Okay. See dissolved radioactive pollutants. Okay. Water and aquatic food integration, food milk injection. Okay. Exposure and deposition, inhalation, and cosmic radiation. Okay. Actually, see, actually radiations come from everywhere, okay, not only from the earth surface, okay, or from the extraterrestrial sources, okay, or from the other things like this. See, very first thing is that cosmogenic radionuclides, okay, means it comes from the cosmic showers, okay, or cosmic radionuclides, okay. Best new radionuclides, most of the time you people are studying about carbon 14, you know, right, okay. Where exactly carbon 14 which comes from, okay, which come from the cosmic rays, okay. Cosmic rays means these are the radionuclides which come from the outer extraterrestrial orbits, okay, due to the sunflowers, okay, or whatever the our solar system is there, okay, maybe from the solar system or outside the solar system. But when it coming into the environment, okay, whatever the cosmic rays are there, okay, it produces primary and secondary cosmic rays, okay. That only would come into the Earth atmosphere, okay, and produces C14 and sodium 22, like that. Second thing is that anthropogenic, okay, radionuclides means man-made. Okay, any idea about man-made radionuclides? Where exactly come from? Hmm? Man-made activities. Okay, man-made activities like nuclear explosion. Okay, nuclear reactor, nuclear medicine. Okay, all these things comes under anthropogenic radionuclides. Okay, so these are the main radionuclide elements. One is that cesium, okay, cesium 134, iodine, and strontium. Okay, actually cesium 137 and strontium 90. Okay, it both are very easily come to the food chain easily because of that. Both are bone seekers. One is the bone seeker, another one is muscle seeker. Okay, because the chemical formation exactly go to the potassium. Okay, that's what it comes into the body very easily. See, and one more thing is the terrestrial radioactivity. Okay, terrestrial, that's what I said. Radioactivity is everywhere, including the human body. Okay, means even the soil. Okay, for example, if you go to the your ground, okay, take one survey meter, gamma survey meter, and you check it. Okay, you will get some activity. Okay, level may be different. Okay, if you go to the, if I think in nuclear physics lab, you people have GM counter and all. Okay, right. Okay, I think you people done the experiment of beta activity and all. Okay, same thing. What you done with the GM counter, okay, the same GM counter where you just converted into the small gamma ray spectrometer. Okay, using that one we are going to calculate. Okay, what is the activity is there. But you are using the small sources right in the lab. Okay, but you can use it big. So whatever the terrestrial sources are there means soils and granite, anything you can calculate. Okay, what is the radioactivity? Same thing here. See, okay, in terrestrial radioactivity means whichever the radioactivity which come from the Earth surface. Okay, for this one, three major radioactive series are there. One is that uranium series, thorium series, and potassium, and both are singly occurring radionuclides. Okay, so these are the parental element, uranium series and thorium series. Remaining radioactive elements are very much important. Okay, say polonium. See, I said why Marie Curie was famous. Okay, because she invented the radioactive material. Okay, that's what she put it. Polonium. Okay, she is from the Poland. Okay, for mother country, she put it the name polonium. Okay, that's what Poland into the polonium. Okay, radium also she only invented. Okay, these are the some thorium series. You know what is the half life of uranium series and thorium series? Hmm? A. So what is the half life? I think you people done an experiment in lab, right? That's what I said. GM powder experiment. Okay, normally you are using some beta sources, right? What is the half life of that one? Which source you use it there? Huh? Cobalt 60. What is the half life? Hmm? How much? How many years? Hmm? Oh, okay. What are the another radioactive elements from cobalt? Isotope. Cobalt 57. Use ಮಾಡಿಲ್ವಾ? Okay. Only cobalt 60 use. Okay. So saying whatever the cobalt 60 or 57 is said, okay, that is both radioactive, that is the man-made. Okay. But I am talking about here the natural radioactivity means these are the radionuclides already is available on the Earth's surface. Okay. You know which country has more thorium in the world? Thorium. Yeah, thorium content. Okay. Many times people are watching news, right? That time people get it. News like, yeah, especially Iran war. Okay. Why USA and Israel conducted the war on US, Iran. Okay. The basic idea is that they have a nuclear weapon and all. Right. Okay. Where exactly come from uranium. Okay. Uranium just we are processing it from the soil only. Okay. Or where exactly uranium get more. Okay. But India is one of the richest country in thorium. Okay, 99.2% of the thorium throughout the world is found in India only. Okay, and these are the some data radionuclides. Okay, you know half life of uranium and the thorium series. Okay, around 1.5 billion years. It's not a small thing. It's a very huge. 10 to the power of 9 and 10 to the power of 10. Okay, that is what the half life. Okay, and whatever the radium is there. See, this is the available in bone up to 90 millibecquerel per kg. Okay, anybody's bone or bone samples if you take it. Okay, and if you test the radium activity or polonium activity, definitely it will be there in every single individual. How it come from means see what I said, the cosmic rays. Okay, all the cosmic rays one or the other way from primary particle and secondary particle comes to the atmosphere. Okay, it will be observed by your plants. Okay, or whatever the radioactive materials are there in the surface. Okay, that one will also observed by the same plants. Okay, when you are eating that particular food, crabs, okay, tomato, onion, anything if you are eating. okay, it will come to your digestive system based on their radiochemical parameters, okay, it will go to the different parts of the body. That's it. Okay. And one more thing is that many times people are watching advertisement, right? Okay, about tobacco. Okay. Why tobacco causes cancer? Hmm? Yeah, what's the reason to cause cancer in tobacco? Okay, even if you are chewing or smoking. Okay, what was the reason? Hmm? Simple. The idea behind the cancer causing due to the tobacco is okay. One is that primary thing. Okay, whatever the cosmic rays will come. Okay, or the cosmic particles just during the night time, cosmic shower is very high. Okay, some particular locations. Okay, so what happened? Tobacco leaves are there now. Porosity is very high. Okay, I think people from the botany background you get to know that. Okay, what is the porosity of the leaves? Okay, when the porosity is very high, okay, it will be absorbed by the leaves. Means what are these radionuclides, especially radionuclide like polonium. When you are converting that one is to the tobacco leaves into the tobacco after processing, okay. When you are if you are eating or even smoking, okay. Why as compared to the eating, smoking is dangerous means the smoking temperature is around 400 Kelvin, right? Okay, in 400 Kelvin, whatever this polonium is there, it will be completely becomes gaseous form and go to the lungs, okay. But the energy is around 5.4 kilogram. So sorry, it's highly carcinogenic, okay. Energy range also 5.4 MeV. Okay, such energy range. Due to that one, it causes cancer. Okay, that is the main reason. Okay, why if you are inhaling, okay, or eating the tobacco or chewing the tobacco, why it causes cancer means the reason is that energy range. Energy range is around 5.4 MeV. Okay, and it have a lot of polonium. Okay, because of an high temperature when you are smoking, now due to the high temperature, easily it will go to your lungs. Okay, when it go to the lungs, automatically 5.4 MeV is high energy, okay, and directly it's a carcinogenic. That's what it produces. Okay. Same. Next one, this is ionizing radiation percentage. Okay. See the chart here. Okay. What are the different radioactive materials? Okay. And now people are exposing. Okay. See here, very first thing is that radon. Okay. Internal radioactivity, terrestrial. Next one is cosmic. Okay. And consumer product, nuclear medicine, and medical X-rays. Okay. Which one shows the maximum there? Okay, maximum percentages come from the radon, right? 58%, which means that once if you are staying inside the house also, okay, whatever these materials are there, even this wood also, okay, it produces radon. Okay. Whatever the wall, everywhere, okay, all the materials, what are the materials you manufacture, what are the materials you are going to use in this universe, okay, everything one or the other day, percentage may be different, that's it, okay, but if you calculate the radioactivity, every particle, every material have a radioactivity. Okay, but we are telling about radon 55%. Reason is that okay because of inhalation. Okay, radon percentage. For example, if you calculate the radon activity in Shimaga district, if take it, okay, there are so many papers published. Okay, just Google it. Radon percentage in water of Shimaga district. Okay, you will get to know that. My friends only from Coimbatore University. Okay, your university Shimaga. They published many paper on radon and uranium in Shimaga district. Okay, where exactly if you go to the higher depth around 300 feet, 400, 500 feet. Okay, radon activity is more. Okay, when you are inhaling, okay, because that one also carcinogen. Due to that one, it causes a lot of cancer. Okay, you know what is the cancer patients in Bangalore? Any idea? Okay, even Karnataka. Hmm? How many? What is the population rate in Karnataka presently? 6.2 crores. Right. Okay. How many cancer patients presently? Up to 4 lakh cancer patients are there in Karnataka itself. Okay. Out of that one, in Bangalore itself, 40 to 60,000 cancer patients. It may be oral cancer, breast cancer, okay, or other different types of cancer. All together, there is 4 lakh cancer patients only in Karnataka. Okay. The reason is that this carcinogenic radionuclides. Okay. Many times people are thinking about other radionuclides. Okay. Other cancer causing. Yeah. Most of the time you are talking about plastic, right? Okay, plastic will causes cancer. Okay, other times we are telling about what are the smoke which come from the industries. Okay, carbon monoxides and chemicals. Okay, more than that, this one causes cancer, but we are not aware of that one. Reason is that very simple. Okay, only few members doing the research throughout India. Okay, yeah, we have seen that one. Okay, because if you take in Karnataka, only few members are already doing the research related to the radioactivity and all, because all the instruments are expensive. Okay, that's what nobody is touch that particular part, okay, because it's highly research instruments, even everything is too expensive if you compare it with the nanoparticle synthesis and other things, okay. That's what's very rare. And one more thing, nuclear technology in graduation or post graduation also, okay, only few people are interested to learn nuclear physics, okay. 95% of the people are interested to study solid state physics, okay. Reason is that it's easily available, okay. Anything if you want to do with the solid state physics means easily we can do it, okay. But nuclear physics are not like that, okay. You know BRC, all of you know the BRC, yeah, what's the full form? Bob Atomic Research Center, right? Okay, once you finish your post graduation in physics, okay, or chemistry, okay, there will be a lot of opportunities there. After BSc also, many times they will call for the technical post in BRC. Okay, you apply there if you are interested in nuclear physics. Okay, day by day. Actually, it's very interesting things you can do it there. Okay, if you are interested in PhD also. Next one is radionuclides in riverine environment. Okay, actually, this is what I took it as a challenging work. Okay, during my PhD, how radioactivity related to the river. Okay, any idea why rivers are very much important in India? Okay, not only India, wherever the population is there throughout the world, okay, in all the population we segregated, okay, based on the rivers only, okay. For example, if you take Harappa Mohenjo-daro, okay, Sindhu Nagarikate, all these things already know that one, right? Okay, why Sindhu Nagarikate comes only in the basin of Sindhu means, okay, there is a river, easily available thing is that water. If you have a water, you can cultivate the lands, okay, we'll get to a different type of crops and all, okay, it's easy to run our livelihood, right, okay. So that is a basic idea, okay. And one more thing is that pollutants, okay, most of the time river pollution is normal, common thing, okay, especially in India, okay, if you go to the Bangalore, okay, so many rivers are there, Arkavati and all, okay, all the time Arkavati river, if you see that one is like a bit drainage, okay. Problem is that there is no proper rules, okay, and there is no cautious things done by the industries and all. Okay. So that's why I was very much interested to calculate the radioactivity in soils and sediments of river, okay, as well as the water things. Okay. So what are the geology and the mineral things? Okay. Normally, most of the radionuclides are influenced by the geological parameters of the particular area as well as the minerals. Okay. Why minerals are very much important means for any body. Okay. For example, human beings are there. Okay. What are the food if we eat? Okay. If it is a lack of minerals means, oh, okay, you will get very easily the any health issues and all. Right. Okay. Reason is that minerals. Okay. Even any most of the time, okay, that's what we drink mineral water, right? Okay, to maintain the constant temperature of our body. So objective, these are the main objective to calculate the radiation throughout the area, okay, and other activities, okay, and measurement in water. So these are the instruments you are using. Very first thing is that gamma ray survey meter, HPG survey meter, alpha counter, RAD7, FAR, and magnetic receptor. This is the gamma survey meter. Okay, you can use that instrument and you can measure the gamma survey. Okay, and this is the HPG detector. Okay, I think in theory people may study that one. Okay, what's the hyperbaric germanium detector? Okay, or scintillating crystals normally studied. Okay, that is the thing. Next one is the calculation formula. This is alpha counter. Okay, alpha counter is similar to your GM counter only. Okay, but in GM counter you are using GM cube. Okay, right. But here we are using ZNS crystal. This one film. Okay. Next one is this one is RAD7. Okay, actually we procured by USA. Okay, to measure the radon in water. Okay, this is the FAR instrument. Okay, and this is magnetic susceptibility meter. Okay, using this one you can calculate magnetic susceptibility. Okay, for both things. One is that impurities in water or any soil sample, sediment sample, and all. Okay, these are the areas we took it local samples throughout the Kaveri River basin and Yamavati River basin. Okay, yeah. See, this one is the radiochemical lab. Okay, what about the polonium I said Marie Curie invented? Okay, my research topic the same thing. Okay, I extracted around 500 polonium samples. Okay, during my PhD, it's not so easy to have. Okay, if you want to work to extract the polonium means at least you have to spend 2 days continuous rigorously. Okay, to extract 3 to 4 samples. Okay, rigorously. You have to sit in chemical lab. Okay, chemistry lab. If people have seen only 2 hours a week, okay, or 3 hours a week, right? Okay, now we normally sit in the lab from morning 10 o'clock to next 5 o'clock, okay, to extract samples. Okay, it's a tedious work, but this is a simple thing. Very first thing is that we took the soil samples, okay, and extracting, okay, whatever the organic matter and other things are that we are just digesting using HNO3 and all. After that, we are drying that one, okay. Finally, we'll get white residue. Okay, that residue we are just depositing onto the silver planchets. Okay, silver planchets directly we will put what you people see many times you people not aware of that one. Okay, what is the use of this particular theory and what is the use of this particular beta counting and all? Right, you may get that out. Okay, many times, right? Okay, so this is the way. See, whatever the theory people are going to study in your graduation and post graduation, okay, nowhere we apply directly. Okay, in different way, in different set of instruments. For example, if people are learning XRD, right? Okay, or what you call crystallinity, crystal structure and all. Okay, but that one will not come directly. Okay, where if you are taking some particular topic, for example, if you are interested in crystallography, okay, then you are going to use it. Okay, or if you are very much interested in radioactivity, okay, and nuclear experiments, then you are going to use how to calculate this beta activity, gamma activity, and all. Okay, otherwise there is no use at all. Okay, yeah. See, whatever the syllabus is there, we are structured in one particular way. Students should know all these things. Okay, but when you enter into post graduation or research level in PhD or in post graduation, if you are going to do the projects and all, okay, that time you are going to use it. Okay, in your graduation, definitely many times you are learning how to do the experiment. Okay, but that application of the experiment will come later stage of your life. So this is what radiochemical laboratories. Okay, and radioactivity concentration aquatic samples means we collected so many water samples throughout the Yamavati and Kaveri river basin. Okay, we collected the aquatic samples from each location. Okay, and we measured the radon using the radon instrument. So see, this is the results I will show you. Okay, see, this is what gamma activity. See that throughout the river basin. One is that Kaveri River, another one is Yamavati River. I comparing with the Nile River, Alakananda, Indian Range, and World Range. Okay, so in both the locations, it's above the Indian average and world average. Okay, both in Kaveri as well as the Yamavati River. I will show you polonium activity. See, these papers already we published. Okay, different journals. Okay. Yeah, this is what polonium activity in river basin. Okay, we calculate both pre-monsoon and monsoon, and we publish this paper. Okay, and these are many papers we publish using the data. These are okay, same thing. And mineral analysis we done it. Okay, and this is recent papers. Recently we done this new work. Okay, yeah, sorry. Thank you. Any questions? See, this presentation actually completely based on research and all. Okay, but if you are interested to do post graduation, very first thing, okay, concentrate on your particular subject. Okay, then if you are interested to do MCA, MBA, anything, okay, concentrate on your post graduation thing. Second thing, if you are really interested to do research, means okay, concentrate on particular topic. Okay, I'm really interested in nuclear physics, means nuclear physics. Okay, and jobs. Okay, many people don't know that one. Many jobs vacancies are still available in BRC. Okay, ISRO. Plus, there is also for graduation and post graduation both level. Okay, so try. Okay, one thing is that always try to get notification. Try to get the notification. Once you receive that notification, it's very easy. Okay, always search it. Okay, whether jobs are there or not. What's going on in big industries as well as the what you called government agencies like BS and all.
Chaitra essay. She is going to explain about salt doped polyvinyl alcoholics for sustainable packaging applications. Followed by Chaitra essay, I request Kaushik B. Pujari. Please be ready.
Sir. Pointer ಎಲ್ಲಿಟ್ಟಿದ್ದಾರೆ please? Pointer ತಗೊಂಡ್ರೆ. Point. ಅವು ಅಷ್ಟು ಅದ್ ಬೇಡ ಅದ್ ಲಾಸ್ಟ್ ಅಂದ್ಬಿಟ್ಟೆಲ್ಲ ಬೇಕಂತ
Hello, am I audible? Am I audible? Oh. Good evening, everyone. Myself, Dr. Kantraj. I'm working as a lecturer in Sayadri Science College. Respected sirs and dignitaries here, I would like to start my presentation with your permission. My work is based on the diversity of agaricales, a group of fungi, macrofungi, that is we all know as anabe. ಅಣಬೆಗಳು ಅಂತ ಕೇಳಿದಿರಲ್ವಾ, ಅಣಬೆಗಳು. ಆ ಅಣಬೆಗಳ ಡೈವರ್ಸಿಟಿ ಬಗ್ಗೆ ನಂದು ವರ್ಕ್ ಇದೆ. ಆ ವರ್ಕ್ ಅಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಪೀಸ್ ಆಫ್ ವರ್ಕ್ ಲಯೋಫಿಲೇಸಿ ಅನ್ನೋ ಒಂದು ಫ್ಯಾಮಿಲಿ, ಆ ಫ್ಯಾಮಿಲಿ ಅಗ್ಯಾರಿಕೇಲ್ಸ್ ಅನ್ನೋ ಒಂದು ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಟ್ಯಾಕ್ಸಾನಮಿ ಗೊತ್ತಿದ್ರೆ ಅದು ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಈ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರುವಂತ ಒಂದು ಸಣ್ಣ ಗ್ರೂಪ್ ಆಫ್ ಅಣಬೆಗಳ ಬಗ್ಗೆ ನಾನು ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಹೋಗ್ತೇನೆ. So this is my abstract. First of all, I would like to introduce my study area, that is Western Ghats region of Karnataka. So Western Ghats is a part of one of the 36 biodiversity hotspots in the world, hottest hotspot of biodiversity ಅಂತ ಕರಿತೀವಿ. In that, the Western Ghats covers about 140,000 kilometers and has about a mountain range of 1,600 kilometer length. The mountain ranges elevate from an average of 1,200 meter and traverse from north to south through 6 states of India, from Gujarat to end of the Kerala. So that is the mountain range. So it covers for about 325 globally threatened species in the IUCN Red List. And Central Western Ghats of Karnataka, this is my study area, and it has the part of Western Ghat running through the state of Karnataka. It covers about 5 districts: Uttara Kannada, Shivamogga, Chikmagaluru, Hasna, and Kodagu. Different vegetation patterns account for the diversity of various group of animals and flora and fauna, and especially fungi. Fungi are so Lyophiliaceae. It is a group of fungi ಅಂತ ಹೇಳಿದೆ. So it is a part of tricholomatide clade ಅಂತ ಕರೀತೀವಿ. In the phylogenetic systematics, it comes under tricholomatide clade, and it includes commonly referred to as these genuses. These genuses and all these genera, with exception to ossicolix and clitoside, show siderophilous granulation in their structure. And Termitomyces, it is one of the most commonly found fungi. We all know it as a ಹುತ್ತದ ಅಣಬೆ. ಹುತ್ತದ ಅಣಬೆ ಅಥವಾ ಅಕ್ಕಿ ಅಣಬೆ ಅಂತ ಕರೀತಾರೆ. ಅಣಬೆ ಇನ್ನೊರಿಗೆ ಗೊತ್ತಿರುತ್ತೆ. ಅಕ್ಕಿ ಅಣಬೆ ಅಥವಾ ಹುತ್ತದ ಅಣಬೆ ಅಂತ ಕರೀತಾರೆ. ಆ ಹುತ್ತದ ಅಣಬೆಯನ್ನ ನಾವು ಟರ್ಮಿಟೋಮೈಸಿಸ್ ಜೀನಸ್ ಅಲ್ಲಿ ನೋಡ್ತೀವಿ. The present study presents 6 species of Lyophiliaceae members. 6 species from Western Ghats of Karnataka, of which 2 are newly recorded from India. So 2 are newly recorded ಅಂತಂದ್ರೆ 2 species are newly recorded in the distribution of whole world. ಇಡೀ ವರ್ಲ್ಡ್ ಅಲ್ಲಿ ಬೇರೆ ಕಡೆ ರಿಪೋರ್ಟ್ ಆಗಿರುತ್ತೆ. ಆ ಸ್ಪೀಶೀಸ್ ಗಳನ್ನ 2 ಸ್ಪೀಶೀಸ್ ಗಳನ್ನ ಈ ಫ್ಯಾಮಿಲಿ ಅಂಡರ್ ಹೊಸದಾಗಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ವಿ, ಅಂದ್ರೆ ರಿಪೋರ್ಟ್ ಮಾಡಿದ್ದು ನಮ್ ಕೆಲಸ ಆಗಿದೆ. Study area again: tropical dense evergreen forest, tropical sunny evergreen forest, moist deciduous forest, and dry deciduous forests are common in the region of Central Western Ghats. And survey and sampling is mostly specific to rainy season. Fungi ಅಥವಾ ಅಣಬೆ ಅಂತಂದ್ರೆ they come in the rainy season. So it is restricted to rainy season. Time sensitive and random sampling method was used to collect the samples. Field observation is especially done. It is most relevant data for a fungal taxonomist to collect the field data. So field data, for example, substrate type of attachment of ileus, and then shape, surface, and then flesh color. Those are all the things we have collect during the field observation. And a field key was maintained to collect the data. That is from Papri et al. In the 2017. Collection and documentation is especially the field. We took photographs of the specimen, and samples are collected in the polythene bags, and other substance samples are also collected in the microcentrifuge tube for the phylogenetic analysis, otherwise known as DNA fingerprinting ಅಥವಾ DNA based systematics ಮಾಡಿದೆ. Identification and characterization. In this, macromorphological characters are observed in the laboratory. Size and shape of sporocarp, ileus surface morphology, arrangement of lamellae, stipe and its surface morphology, presence or absence of vulva, bulb, and rhizomorph, position of partial weight, annulus ಅಂತ ಕರೀತೀವಿ, that partial weight present or absent, context, taste, and color. These are all the macromorphological characters to be observed during the morphological characterization. And microscopic characterizations like basidiospores, structure and shape of basidiospores, size of the basidiospores, and type of granulation in basidia. Basidial arrangement ಅಲ್ಲಿ granulation ಹೇಗಿದೆ, and type of hyphal system, basidiospore arrangement, pilepelis and its hyphal system. These are all the microscopic characters observed during the characterization. And next major part of my work, that is molecular characterization. It is done by doing DNA based DNA extraction and synthesis of specialized genes for the identification of that organism. So it mainly occurs in five different steps. So first one is DNA extraction. It is done using genomic DNA was extracted using the 2x CTAB method. 2x CTAB method, modified CTAB method, and polymerase chain reaction was conducted using primers given by White and DVS ester. DNA sequencing was done in Eurofin Genomics Laboratory, Bangalore. Sequence alignment was done using bioedit consensus sequences were built using bioedit sequence editor. Obtained sequences are blasted in NCBI database to get the affirmative recognition of the species. Phylogenetic reconstruction was done using various software like MAFT 7.49, guidance for the alignment characteristics, J model test for building phylogenetic tree, and randomized so results and discussion. So these are the 6 species I'm going to report. So first one is Calosabella pudica, second one Termitomyces fragilis, Termitomyces microcarpus, Termitomyces uricus, Termitomyces lipiatus, Termitomyces globulus. These are all the 6 species that are reported in Karnataka, especially in the central western Ghats region. Out of these, Calosabella pudica and Termitomyces fragilis are 2 species that are newly recorded from the Indian subcontinent. These are the microscopic and morphological and microscopic characters that are studied. And molecular characterization, these are the OCHA numbers that I got from the NCBI database. And these are the accession numbers submitted by me. And the electrophoresis results, these are the results got for the extraction of DNA and polymerase chain reaction. DNA sequencing and gene bank data sheet of that species. And the phylogenetic reconstruction was done by using 17 combined sequences of nuclear ribosomal internal transcript spacer and R substituted DNA. About 1,302 distinct parameters are used for the reconstruction of DNA, and these are the specimen sequences used for phylogenetic reconstruction. This is the final phylogenetic tree by which the identification is confirmed. Here we can see Calosabella pudica is restricted to the Calosabella pudica branch, and that confirms the identity of the fungi. And likewise, all the species were scored most and confirmed the identity. And this to summarize the presentation, the research documents 6 species belonging to Lyophiliaceae, and species distribution was higher in case of dry deciduous parasitism due to the availability of substrates. And the study presents 2 new species records from Indian subcontinent. All the 6 species were documented by observing macromorphological and microscopic characteristics. Phylogenetic reconstruction was carried out using advanced parameters and advanced software versions, and the utilization of molecular techniques led to the unambiguous identification of species. And these are the photographs of mushrooms. references. Thank you.
Nice presentation, sir. Nice presentation, sir. Thank you. It's the time for discussion. Any one or two questions from the audience? If there are no questions, we move on to the next session. No questions?
Thank you, Ananda.
Thank you. Thank you, Professor. Now, I would like to invite Chaitra SN. She's going to explain the entire child over.
Good evening, respected organizers and participants. My name is Kaushik Pujari from the Microtron Center, Department of Physics, Mangalore University. Today I will present my work titled Effect of Calcination Temperature on Optical and Dielectric Properties of Barium Titanate. So this work studies how changing the calcination temperature influences the optical and band gap and dielectric behavior of barium titanate nanoparticle synthesized using aloe vera extract. So first I will briefly introduce the material, then discuss the synthesis method. After that, I will present the UV visible optical analysis and dielectric properties. Barium titanate is an important ferroelectric ceramic material having a perovskite crystal structure. It is widely used in electronic devices such as capacitor, sensors, actuators, and energy storage systems because of its high dielectric constant and low dielectric loss. However, the properties of barium titanate strongly depend on crystallinity, grain size, and defect concentration, which are influenced by the calcination temperature. In this work, we synthesized barium titanate nanoparticle using aloe vera extract through a green synthesis method, which reduces the use of toxic chemicals. The main precursor used were barium nitrate and titanium isopropoxide. Aloe vera extract was used as a natural reducing and stabilizing agent. Ethanol, NOH, and distilled water were used during the synthesis process. First, aloe vera extract was prepared by boiling and filtering the plant gel. Barium nitrate was dissolved in distilled water and TTIP was dissolved in ethanol. Then aloe vera extract was slowly added and the pH was adjusted to around 7 to 8 using NaOH. A precipitate was formed which was filtered, washed and dried. Finally, the powder was calcined at 500 degrees Celsius and 600 degrees Celsius, pressed into pellets and coated with silver paste for dielectric measurement. Results and discussion. The UV visible spectra of both samples show strong absorption in the ultraviolet region below 350 nanometer, which is typically for wide band gap material like barium titanate. We observe absorption peaks at 337 nanometer for the 500 degree Celsius sample and 334 nanometer for the 600 degree sample. This absorption corresponds to the oxygen 2p2 titanium 3D electronic transition. A slight blue shift is observed with the increasing calcination temperature, indicating changes in the electronic structure and improved crystallinity. So, the optical band gap was calculated using torque relation by extrapolating the linear region of the torque plot to the energy axis. The band gap values were obtained. The band gap decreases from 3.46 electron volt for the 500 degree sample to 3.31 electron volt for the 600 degree sample. This reduction may occur due to the formation of oxygen vacancies, which create defect energy level near the conduction band and reduce the effective band gap. So, Arbach energy represents the degree of structural disorder in the material. In our case, the Arbach energy decreases slightly from 1.9 electron volt to 1.8 electron volt. When the calcination temperature increased, this suggests that higher temperature improves atomic ordering and reduces structural disorder. So, now dielectric properties. The dielectric constant is very high at low frequencies because of space charge or interfacial polarization, also known as the Maxwell-Wagner effect. At low frequency, charge carrier accumulate at grain boundaries, producing strong polarization. As a frequency increases, this charge carrier cannot follow the rapidly changing electric field. Therefore, polarization decreases and the dielectric constant gradually reduces. The AC conductivity increases with the frequency due to the hopping mechanism of charge carriers between localized states. At higher frequency, the probability of hopping increases, resulting in higher conductivity. The 600 degree Celsius sample shows higher conductivity, which may be due to increased defect state and improved charge carrier mobility. Conclusion. This In this work, barium titanate nanoparticle were successfully synthesized using a green sol gel method with aloe vera extract. Increasing calcination temperature improved the structural ordering and electrical properties. The band gap decreased slightly while dielectric and conductivity properties improved for the 600 degree Celsius sample. Therefore, calcination temperature plays an important role in tuning the optical and dielectric properties of barium titanate. Authors are thankful to Microtron Center, Mangalore University, for providing facility to carry out electrical studies. Thank you.
Thank you, Dr.
ಯಾವ ಸಿಸ್ಟಮ್ ನಿಮಗೆ
ನಂದೇ ಎತ್ಕೊಂಡು